All right, so continuing on to number 4 for this exam at least. Again, there are a couple different versions of this problem. It was a particle traveling clockwise in a circle of radius 3 centered at -1,4. I asked for the parameterization of this. So this is, straight out of 10.1. A couple, talking a bunch about circles. I told you that, circles are something you want to know how to parameterize. So, that's, when I'm talking about that in lecture, that's me trying to, harp on, know this. So I think the only thing that really screwed people up was, clockwise or counterclockwise. I sent out an email about it and put it on my review video. I know that got posted a little late, but, it wasn't your only review material, and I did warn you. I was trying to get your quizzes graded before the exam. Again, I sent an email a couple days before, being very explicit about the different parameterizations. So for the clockwise, so let's do X and Y. So circle of radius 3. So, remember, for the, radius, it's going to be R cos theta, R sine theta. This is clockwise. Counterclockwise, sorry, CCW. So to get clockwise, what you can do is just flip the sine and cosine. That's one way of doing it. So this will make it this will make it clockwise. So what we can do then is circle of radius 3. We're going to have 3 sine theta. So this is just notes. And then 3 cosine theta. And then for the center, you just take, this is X, this is Y. You just add those on. And that'll be our parameterization. The other parameterization you can do is, you can take the counterclockwise parameterization and just replace, theta or T with the minus, theta or T. Just put a minus sign in front of theta and T there. So that's a trick for, you're going to do more parameterizations in Calc 3. So one thing that you should start getting exposed to is if you want to reverse the parameterization, reverse, the path that you took, you just, put a minus sign in front of your parameter. Replace all your parameters with the negative. And that'll actually reverse the direction you're going. And again, you'll get more practice with this in Calc 3. You're done with, this kind of stuff for Calc 2. Now you've moved on to series and sequences. And those are, those are fun by themselves, but they don't rely on, this kind of stuff. Okay. So let's continue. So this was part A. Part B asks you to eliminate the parameter. And we had the parametric equations X is equal to ln of t minus 2, and Y is equal to sine of t squared. So for this one, I just want to tell you to be careful. There were a couple people, not a ton, but a couple, who inverted the Y equation. So let me take a step back. What you're trying to do with this is you're trying to solve for t in one of these equations. And so to that end, a couple people inverted the Y equation. And so to do that, you're going to have to, take the arc sign. I don't think this is, as good as inverting the X equation. Because when you take the arc sign, you are going to, restrict the domain. So the domain of arc sign is, I think, -1 to 1, something like that. So I don't think that's a good one to invert. I didn't take points off for inverting that one unless you forgot the plus or minus when you took the square root. Yeah, so that's another thing to be careful of. The other reason this is a bad one here is you have a t squared. You have to take the square root and you're going to get a plus or minus. And again, you should avoid that just because it's going to complicate your equations. The better one to invert is the top one here. So to that end, you just take both sides to the e, or make them exponents of an exponential. So we get e to the x is equal to e to the ln of t minus 2. E and ln cancel out, and so this tells me t t is equal to e to the x plus 2. Now I'm going to take this and just plug it into the y equation. This will give me a Cartesian equation. Y is equal to sine of e to the x plus 2 all squared. And that's, all I was looking for. You didn't have to expand that out. A couple people did. Okay, so move on to number, I guess, 5? Yeah. So number 5, again, which one you get, the values change depending on which one you get. So find all values of t where the parametric or the curve given by the parametric equations x is equal to sine of 4t, y is equal to sine of t, and t is between 0 and pi over 2, has horizontal, horizontal or vertical tangents. Okay, so this is section, I think, 10.2. So it's just, your vertical are where your horizontal are where dy dt is equal to 0, and dx dt is not equal to 0. If that is the case, you have to do limits. I'm just going to go ahead and spoil this. You don't have to use limits for this one. I'm not that mean. So, dy dt here is just cosine of t. And so you have to solve this trigonometric equation. This one has, t is equal to pi over 2, 3 pi over 2, etc. But we're only looking between 0 and pi over 2, so I can ignore all those. So I just get t is equal to pi over 2. For the vertical, we're going to do dx dt is equal to 0. dx dt is 4 cosine 4t. So this is the same thing if I divide by 4 on both sides. Cosine of 4t is equal to 0. And what that means is, I want the thing inside the parentheses 4t to be equal to, what I just wrote down, pi over 2 or 3 pi over 2, whatever you like. Let's go ahead and get one more just so I can make an example. I didn't require this, but it'll show you what else can happen. And so that means t is equal to, I just divide all of these by 4, pi over 8, 3 pi over 8, 5 pi over 8, so on and so forth. Again, I gave you the restriction that t was between 0 and pi over 2. So 3 pi over 8 is less than pi over 2. So anything higher than that I ignore. And these are my vertical tangents. And these are my horizontal. I didn't need you to find the x, y values. I made that very clear. I said label which values of t. What else did I want to say? Notice that they don't have any in common. Pi over 8, 3 pi over 8, and pi over 2. If they did have them in common, we'd have to, look at the limit of for the derivative dy dx and see what that is actually going to determine if it's a vertical, horizontal, or neither. But again, I didn't test that on this because I wanted this to be, a little more straightforward. But yeah. So let's move on to number 6. So this one, I think, this one is one of them, probably the more difficult one on the exam. So my My idea with exams, quizzes and homeworks, or the homework should be the hardest thing for you to do. You have the most time and the most resources for homeworks. Quizzes I use to make sure that you've seen the material, you understand the basic concepts. This should be, hang on, t squared plus 1, okay. This should be your first time seeing some of this stuff. So for the quizzes, your first time being tested over it. I don't expect a lot. I want to give you something to challenge you, but that's not going to completely try and trick you. With exams, I want to go a little further than I do in quizzes, but not beyond the homework. When I'm making these exams, I typically look at the homework to get an idea of, an easier problem. But yeah, so this one, again, gave a lot of people trouble. So we want to find dy dx, d squared y dx squared, and intervals of concavity. What I mean by that is where the graph is concave up, concave down, concavity. First one's an A. That's what I was saying. C-O-N-C-A-V-I, C-A-V-I-T-Y. Okay, so we need to compute our derivatives here. So dy dx is going to be dy dt divided by dx dt. A couple people tried eliminating the parameter. It's not a good idea here because even though that you can convert this one pretty easily, when you eliminate the parameter, you're going to be left with an equation that is much more difficult to work with versus the parametric equation. Think about the circle. For that, it's going to be x squared plus y squared is equal to something. Whereas the parameterized form of that is just cosine theta sine theta. It's easier to work with that. So let's go ahead and calculate these. So dy dt is going to be 1/2 e to the t over 2. So I use chain rule there. So e to the x derivative is e to the x. But because it's not just x up there, I take the derivative of the exponent up there. Derivative of t over 2 is just 1/2. Dx dt is 2t. So this derivative actually has a very simple form. It's going to be 1/2 e to the t over 2 divided by 2t. d squared y dx squared is a little harder. Nothing crazy though. This is going to be d by dt of dy dx divided by dx dt. So what I'm going to have is d by dt of 1/2 e to the t over 2 divided by 2t. dx dt is 2t again. So I have to use quotient rule up top, but it's, again, nothing crazy. So derivative of the top there is going to be 1/4. Derivative of the top times the bottom. So 1/4 times e to the t over 2 times the bottom times 2t minus the top times the derivative. So minus the top times the derivative of the bottom. So this is just 2 down here. Sorry, I shouldn't have a 2t down there. And then all of that divided by, all of that divided by the denominator squared. So just chain rule again. So that's the derivative of the top there. I'm going to divide that by 2t. Simplify this a little bit. So this is going to be 1/2 t e to the t over 2 minus e to the t over 2 divided by 2t cubed. And this will end up being, if I factor out an e to the t over 2, times 1/2 t minus 1 divided by 2t cubed. This is the second derivative, and that's, final answer. I don't want to simplify it anymore. There's not much I can do. For intervals of concavity, concave up and concave down. So concave up is where the second derivative is positive. Concave down is where the second derivative is negative. So we talked about this in class. I was relying a little bit on your, knowledge of Calc 1, how to solve these. And I think this is where, it threw off a lot of people. So the way we solve the way we figure this out is we find the zeros. I think there's supposed to be an E there, right? Yeah, I'm a mathematician. Not a, I don't know, a speller, I guess. So find the zeros of d squared y dx squared and where it doesn't exist. So most people found one or the other. So if I look at this, notice that it does not exist at t equals 0. And it has a 0 when the numerator is equal to 0. So if I set the numerator equal to 0, I'm going to get e to the t over 2 times 1/2 t minus 1 is equal to 0. You can divide both sides by e to the t over 2 because it's never 0. It's always positive. 1/2 t minus 1 is equal to 0. If I solve this, this is t is equal to 2. So what I do now is I create a, one of these sign charts where I section off all the places where the derivative is 0 or doesn't exist. And I just pick a number to plug in. Here. So d squared y dx squared, I'm going to evaluate that, at -1. I don't even need to figure out what the number is. I just need to figure out if it's positive or negative. So this is going to be e to the -1 over 2 times 1/2 times -1 minus 1 over, so that 2t cubed, I'm going to make 8 -1 cubed. 2 became an 8 because 2 cubed is 8. And then the cube also goes on the t there, so it goes with a -1. Now you just need to figure out if this is positive or negative. So this first thing, e to the 1/2, is a positive number. And then I have -1/2 minus 1. That's going to be a negative number. And in the bottom I have -1 cubed times 8, so this is going to be a negative number. So I have, two negatives and a positive. This is a positive thing. So this thing here is positive between -infinity and 0. Between 0 and 2, I know some of these, some of these weren't as nice as I'd like them to be. You got, fractions. It's still not difficult, so even with those, you should be able to plug in and do what I'm doing here and just seeing if they're positive or negative there. So this is going to be e to the 1/2 times 1/2 times 1 minus 1 divided by 8 times 1 cubed. So again, I'm not writing equals here. This is going to be a positive. E to the 1/2 is always positive. 1/2 minus 1 is going to be a negative number. That one you can actually figure out if you really want to. I don't. And then bottom, 8 times 1 is a positive number. So this thing is negative. So here I get a negative sign, and I can do the same thing with something like, I don't know, 3, I guess. So this is going to be e to the 3/2. Yeah, that looks like it too. Times 1/2 times 3 minus 1 divided by 8 times 3 cubed. So e to the 3/2, again, that number is always positive. 3/2 minus 1 is a positive number. Denominator is positive. This is greater than 0 here. So my interval, so I'm concave up from -infinity to 0 and 2 to infinity. And I am concave down from 0 to 2. And that is what I was looking for. So that, again, longest problem. I have the most work for that. So I think I started this, about 10 something, and it took me an hour to do, showing all my work and, talking to you guys. So just kind of a, just things to watch out for on this problem, and explain why some of the points got taken off, because again, I have to grade 180 of these. It's hard to leave, detailed feedback on every single one of them. These videos are supposed to remedy that a little bit. I need to see work for how you determine the intervals of concavity. Inequalities, you don't want to solve. So let me make a note of this. You don't want to don't solve with inequalities. So you use these sign charts, and let me explain why. So you should have, been explaining this in your Calc 1 course. So we have e to the t over 2. Is it 1/2 t? Yeah. 1/2 t minus 1 over 8t cubed. Let's say I'm going to try and solve this with an inequality. Let's say I want to figure out where this thing is positive. So the first thing you're going to do is you're going to say, okay, let's multiply by 8t cubed. That'll be your first thing that you're going to do here, because you're trying to solve an inequality. And when you multiply that over, it's going to annihilate on the right hand side. The problem though. So my question is 8t cubed positive or negative? And the answer to that is it depends. Is t positive or negative? And so, when you try and solve these using inequalities, the work gets much more complicated. You have to now break this up into two cases. Is t positive or was it negative? And if t is positive, if t is greater than 0, I can multiply the inequality without worrying about the inequality changing direction. But if t is negative, then t cubed will be negative, is what I'm getting at. And when I multiply an inequality by a negative number, I have to flip the direction of the inequality. So you can do these with inequalities. It's just you have to be very careful, and it's much harder. So Calc 1, you should have seen how to do these. And in my example, in the example I did in the lecture slides, the functions were easy enough that I could look at it and say, okay, this thing is always positive, and this thing changes sign here. So that was actually the example I did. It was the numerator was always positive. The denominator very obviously changed signs at t equals 0. You can't do that here because it's more complicated here. The top's not always positive. It changes sign somewhere. So, looking at your homework, I saw that you guys had more complicated things that you should have, had to do this stuff on. So I figured it would be, something that you guys were brushed up on by now. So I think that's all I have. So this will be, my last video. I'm finished teaching for the semester. I'll be teaching, in the fall. I don't know what I'm teaching. Could be Calc 3, and I don't know if any of you guys want to take it with me anyway. I've gotten the sense from a couple people at least that, everybody learns different, and my teaching style is not going to please everybody. But anyway, so if you have questions about this, first half of the semester stuff, I have my office hours. Just let me know beforehand. I'm going to have office hours. I'm posting this on a Sunday night. I'll have my office hours on Monday. I'm going to send a link out to everybody, just because I know a lot of people want to talk about their exam, and I think this should answer a lot of questions, hopefully. And if not, we can always chat about why I took off points. So I'm going to stop the video here. If you have any questions or see any mistakes, it's the only thing I'm worried about making a mistake on here is I'm worried that I screwed up a minus sign in here somewhere. It's not likely, but it happens. So I'm going to stop the video here. Again, if you have questions, feel free to reach out to me. You all have my email. I'll try and be good about responding. Sometimes an email gets lost, but So I'll stop here and post this.